So we're about to remove the two failed components in this heat pump. Unfortunately, the evaporator is actually what is failing. You can see there's an oil spot right there. We've got an oil spot right here. It's kind of hard to see. We've got an oil spot here, 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 here. And that looks kind of like an oil spot. There's another one there. They're actually easier to see on camera than they are in real life. But yeah, 1, 2, 3, 4, 5, 6, 7, 8, and then this corner down here is just full of them. And you can actually, I just added 10 psi into the system, you can actually audibly hear it hissing. Not exactly sure where in there the primary leak is, but it's bad. So we have a whole new evaporator or condenser coil. It's really able to do both, since this can both do heating and cooling. This is a ground source heat pump, so you can see we've got a couple of lines coming in from our loop field and our water heat exchanger slash evaporator down in the bottom there. Pretty neat system. But when we take this out and put the new one in, as you can see right here, our liquid line comes in. Back there's our suction line, so we're probably gonna have to pull off that back panel too. We're also going to replace that liquid line filter dryer down there. This right here is just a muffler slash accumulator on the high side line. Not accumulator, muffler slash receiver on the high side line. You can see the line comes out of the compressor, this high side line, and then I'm not sure if this is supposed to be an oil trap or what, but it goes up and then back down into that muffler receiver. I do not think this system has an accumulator anywhere on it, which is kind of interesting. Seems like it would want one, but nope, just the liquid line filter dryer. Unless there's one somewhere down in this foam mess. We think that this is still okay, which hopefully it is good to go. It doesn't seem to be leaking water or anything. I had to pull the return air off in order to get at the coil, and now we're going to somehow remove this panel. I just got the old coil removed, and I'm not super happy with the way this is coming apart. We've got all this weight of the ductwork sitting on top of here, so everything's really not great. And also there's a post over here. So what I ended up doing is kind of just tweaking this up and then pulling this out enough so I could get at the coil. And I should be able to braze right here. So I now have the new filter dryer. It's just dry fitted right now. Sitting there ready to be brazed. As you can see, I wet ragged this very thoroughly. It's up here. Just using a 7/8 coupling right here to join those two together. And then in here we're just using 3/8 coupling. And we were able to deburr. We've got 3 screws on this side, so that's where the coil is gonna sit. So I should be pretty much ready to just start brazing this thing together. So the system is now all brazed in. You can see I checked these fittings for leaks first, put some pressure in the system, soaped the fittings, and then made sure there was nothing bubbling down there too, and over there. Then I hooked up the vacuum pump. Now we're just sucking it down. Gonna let the vacuum go for a while. I'm gonna go and get some insulation, various bits of insulation to repair what's been opened. So I got all that stuff re-insulated. So over here on the sticker we can see that this unit contains 81 ounces of R410A. I used silicone to seal up any of the spots where air could infiltrate, and then re-insulated those lines back there, so we should be in good shape. Alright, so a good solid hour has gone by. I'm really pleased to see that our microns pulled down into the 500 range. We're going to go ahead and shut the vacuum pump off and let the system sit for 7 minutes. If our microns travel up above 1,000, then we know there's still moisture in the system. If they travel up above 2,000, then we know there's a leak somewhere. But if they stay under 1,000 for 7 minutes, then that means our system is both tight and dry. So it's actually been a good 10 minutes now since we turned the vacuum off, and as you can see, we've held at 778 microns. So this system is free of leaks and dry. So that's a good thing. Running the vacuum pump for an hour like we did is really good for a system that has had a leak, because it gets rid of all of the moisture and stuff that is in there. It dries it out by lowering the boiling point of the water and then pulls it out of the system. I have to re-insulate all these lines down here, like down by that filter dryer and stuff, because depending on if the system is heating or cooling, that'll actually frost up, since the unit runs backwards when it is in heating mode, so that coil gets hot and that loopy-doo gets cold. I think we're pretty much ready to turn this thing back on and start adding some refrigerant. We'll start adding refrigerant first. So yeah, we're gonna add pressure in so it gets up above 0 or 2.0, and then we'll add on the high side line and then dump a bunch of liquid in. Just opened it up to see if it was sweating. As you can see, we've got moisture accumulating on the loops, so that's a good sign. That's exactly what we want. We've got condensate coming down. Our VSAT dropped lower than it's supposed to because we took that door off. We're going to put it back on. That'll increase airflow through the coil and bring the pressure back up. This line coming out, I would say, is fairly hot. It's not crazy hot. So as you can see, settled back out at around 40. That's with the thermal expansion valve working. Earlier when we had this cover off, there wasn't enough airflow, so the coil got cold, so the expansion valve bulb got cold, so it restricted the amount of refrigerant, and then eventually the airflow warmed the coil back up enough to where the expansion valve opened again, and now we've got 40 degrees.